Hi, welcome to Basics of Amplifiers. In this video, we will go over a thought process in the sense that how building blocks of amplifiers can be thought of and realized in the actual circuits. So let's start with simple potential divider or voltage divider circuit. As you know, potential divider consists of two resistors. You can name the middle resistor as R1 and the right side resistor as R2, and as you can see, the value of these two resistances is 1 kilo ohm each. Now let's connect voltage source of 1 volt in series with these two resistances. Now this wire is going to be the input and this wire is going to be the output of the circuit. Now let's run the simulation. Now the current of 500 microamps started flowing through the circuit. This current will be decided by the value of R1 and R2 both. This current then will flow through R2 and will generate voltage across it. As you can see, the voltage across R2 is 0.5 volts. This can also be calculated using voltage divider formula. Now let's change the input to 2 volts, and as you can see, the output voltage also changes to 1 volt. If we change input to 5 volts, you will get the output of 2.5 volts. As the output here is generated by the current flowing through R2, and as current is determined by the value of R1 and R2 both, changes in the value of R1 and R2 will also affect the output voltage. This can also be observed as that I am changing R2 to low value, you can see the output has reduced. If I increase the value of R2, the output as you can see is going high and output is now reaching near to the input. From the equation also you can see that the output can never reach or be equal to the input if R1 is greater than 0. If R1 is equal to 0, then it is effectively a short between input and output, and thus you will get output equals input. As the output will always be less than the input in all other cases, this circuit can be called as an attenuator, and this circuit only attenuates voltages but cannot provide gain. So out of this circuit, when R1 and R2 both are greater than 0, you will never get gain. But if you see carefully the formula of voltage divider, you will find that you can get gain out of this circuit if R1 or R2 is less than 0 or negative. What is meaning of this? Let's remove R1 and we want to replace the position of R1 with negative R1, but we don't know how to realize negative resistance. Rather, we don't know what is the meaning of negative resistance. So as of now, let's think that there is a black box which does this for us. So if you think what all this black box needs to be doing, this black box should basically add voltage over the input voltage so that we can get gain out of this circuit. The first thing that comes in my mind after this is voltage source. For example, if we want a gain of 2 and the input voltage is 1 volt, then the black box should add 1 more volt over the existing 1 volt of input so that we can get output as 2 volts. We will think later about the use of current source is possible or not. As of now, let's stick to the voltage sources. Let's put voltage source of 5 volts and see if we can get 10 volt at the output. As seen, now we are getting output as 10 volts when input is at 5 volts. So we have achieved gain. Let's try to change load and see how it affects the output voltage. As I am changing the load, you can see that the output voltage is not at all changing. This is because as we have added a voltage source and the voltage sources have capability of providing any amount of current to the load, the output voltage will never change for any load resistance greater than 0. In fact, even if we remove R2, the output voltage will be maintained because the voltage sources are happy as they don't need to provide any current. So the black box we wanted is actually a voltage source. Now let's try if current sources can give us gain. And you can see with the use of current source we are able to get the gain. This is possible because now the circuit current is only governed by the current source, and by dumping the current in the load resistor we are able to get voltage at the output as we want. This is also clear that if we change the value of load resistance R2, we will be able to change the gain of the circuit. As you can see, as I change the load resistance, the output is also changing. However, there are other two possible cases which we could have done, which are putting voltage source and current source in parallel with the load resistance and the input source. If you put voltage source across the input voltage, two voltage sources will get shorted, so this cannot be done. Another way is to put parallel current source across the load resistor. In this case, There will be no effect of current source on the output voltage because output voltage itself is the input voltage and it cannot change regardless of whatever amount of current the current source wants to provide. So the two cases we had analyzed, which are putting voltage source and current source in series to load resistance, are the only two possible cases which we can use to get gain out of this circuit. Now let's put back the voltage source. As seen before, 500 microamps of current is flowing through the input voltage source. Input voltage is actually a voltage signal which we want to amplify. This voltage signal could have been generated using some transducer. The transducer is similar to a voltage source and hence there will be a limit on how much current you might want to pass through the transducer based on its type. In the best case, we don't want to take any current from the voltage transducer, which will make sure the input signal is not affected. To achieve this, we need to disconnect input source from the black box to voltage source. But to achieve gain, we want to set the voltage of the black box voltage source depending on the input voltage. So what we want here is a black box voltage source should work as a dependent voltage source where output voltage of black box voltage source is determined by the input voltage. This means we will need voltage controlled voltage source, or in short VCVS. So let's try to put in VCVS in the circuit and see if it works. As you can see, we have achieved a gain of 2 and no current is being taken out of the input voltage. As you can also see, there is a gain factor of 2 for the VCVS. This factor is nothing but ratio of output voltage generated by VCVS to the input voltage provided to it. And as we saw before, as what we are using here is a voltage controlled voltage source, output will not change if we change output resistance. Thus using VCVS, load independent gain can be achieved. Now let's try putting in current source as a black box. In this case also, we need to separate out connection between input and black box current source because we don't want to push any current through the input voltage source as we discussed before. So similar to VCVS case, what we need here is a current source whose value is dependent on the input voltage source. So voltage controlled current source is what we need here. So let's try to put that and see if it works. As you can see, we are able to achieve gain out of this. If you notice, VCCS is also having a gain factor, which is nothing but ratio of output current to the input voltage provided. So in this case, we need to change the load resistance value to get a required gain of 2. This shows that if we use voltage controlled current source, overall gain will be dependent on the value of gain of voltage controlled current source and also the value of load resistance. This can be considered as an advantage over use of VCVS because we get two variables here with which we can set gain. In voltage controlled voltage source case, overall gain was only determined by the gain of voltage controlled voltage source. So to build an amplifier, specifically voltage amplifier, as we had a voltage as our input, we will need voltage controlled current source or voltage controlled voltage sources. Also we got to know that if you want to use voltage controlled current source, we also need to adjust output resistance so that we will get the required gain. Also using these two building blocks, we are able to achieve zero input current from the input voltage source, which was desirable because we don't want to load the input voltage source. On similar terms, you can also design current amplifier and the building blocks needed are going to be current controlled voltage source and current controlled current source. Like in case of voltage transducer where we didn't want any current to flow from the transducer, on similar terms in current transducer we want all of the current which is given by transducer to affect the output because input current is what we want to sense and amplify. From this we can conclude that the voltage sources are likely to be open and current sources are likely to be short circuited when in use. Voltage transducers also are meant to be used when they are open circuited and current transducers are meant to be used in short circuit condition. These characteristics can also be seen in the symbols of voltage controlled and current controlled sources. In the symbol of voltage controlled current or voltage source, two input terminals will be shown as open and there is no connection between them. In the case of current controlled voltage or current source, two input terminals will be shown as shorted. So to summarize, we need dependent sources to design an amplifier. Also, if you had noticed, I have used resistance as the load. In reality, load cannot always be realized using resistance and capacitive or inductive loads are also possible. We will discuss about them in some another video as the main intention of this video was to think of how the idea of dependent voltage sources can be used to design an amplifier.